sticking around this long. Thank you for making it through grades. It was hard. I'm kidding. It was awesome. Thank you for kicking it off. I appreciate it. So, hey, I'm Nathaniel Quist, Q. I'm not as cool as this Q, but this Q is pretty awesome. I'm a senior threat researcher with Palo Alto Networks. I work specifically with Unit 42. Anybody heard of Unit 42? We have an awful lot of fun. There's a lot of really good blog content. I work within Prisma Cloud. Prisma Cloud is Palo Alto's new, not firewall, but actually cloud security tool and security team. So I actually get to spend all of my day looking at the big, three, cloud service providers. So that's my day-to-day job, which is pretty awesome. Love it. So today I want to talk about something called Rock, and we'll get into that a little bit of the agenda. I wanted to kind of keep the Rock theme going on, so we're going to talk about geology, we're going to talk about new layers, deconstruction, we're going to talk about the cloud, because that's what I do, and we want to do that. We're going to look at how do organizations actually do in the cloud, if they actually do well at all. And then we're going to talk about Rock in a cloudy spot, and shifting sediments. You get the same. Right, so first, what is Rock? Rock has been known by a lot of different groups. It's been called the Iron Group, it's been called XBash, it's been called System 10, Kerberos, Huge Pages, I think that's an amazing name, and then also XRock. What they are is they're a Chinese cybercrime group. What this group does is they focus primarily and 100% solely on cloud infrastructure. That's all they're following. They're following targets into the cloud. All right. So who here is using cloud? Be that right? Good majority of you. And a third of you are going to have a surprise about towards the end of this, which is going to be kind of fun. We're looking at AWS. They work at AWS, GCP, Azure, Alibaba primarily. So that's where they kind of got their start. Using languages like Python, Go, Lua, kind of opportunistic. And they operate primarily out of the Jiangxi province, and then there's some Shanghai registration that goes through. So what this first part is going to be going through is a lot of threat intel on what is this group, how they work, where they came from, what is their methodology, and all that. And you're actually going to be kind of surprised. I was kind of surprised when I first started looking at that. So first of all, what's in a name? The naming actually came from an email address from a registry from one of the domains, that being that rock at live.cn. That was associated with another email address being jxci at vip.qq.com. And then the JX is the short province name, just like Colorado is CO or California CA. Jiangxi is JX. So pretty straightforward on that. New information that we found as soon as we started looking at this is there's a couple other domain registration emails that have come through. This 459.224 occurs both in Gmail and in QQ.com. Anytime you see this IP or this email address being used for registration of domains, you'll always find it a part of Lu Wei's domains. We're not sure exactly if Lu Wei is actually malicious, because he does a lot of legitimate domains, but they certainly use his domains very frequently, which is kind of fun. He's based in Shanghai, and a lot of these domains that are used are also based out of there. So going through how Rock has evolved through the years. First started out in 2016, targeting Windows. They're kind of opportunistic across the board. They were using Windows, Linux, and Android. They didn't even really know what cloud was at this moment. They really weren't caring so much. They were using solely Python as their full language of choice. And they borrowed a lot. They borrowed a lot of data. Hacking teams, remote cool control system, everybody know hacking team and all that. They took a lot of their code out of that, being primarily Soldier and core library. Soldier being VM detection, core library actually looking at the actual function calls of systems. So they basically just stole that code, stuck it in their Python, and off they went. They also stole a lot of Cobalt Strike, not CrowdStrike. You can still CrowdStrike, I don't care, they're whatever. Cobalt Strike, and they probably primarily used the reflexive loading capabilities, the beaconing, and then also they have a pastebin repo usage. This is where Rock and Iron Group actually learned how to actually use pspin as a C2 source. So it's kind of interesting. But as you can tell, they were all script kiddies. They didn't have any details. They didn't know really what they were doing. They were just saying, hey, I want to be able to do some bad stuff and make some money, and so I'm going to use these tools to do it. So it's kind of funny. What kind of made them a little bit interesting is they were actually very security conscious about what it is that they were attacking. When they approached a system or they entered a system and they found that it had any Chinese, basically, security system on it, primarily the 36 safeguard, the 36 internet security from the 36 QHU software company, they would just immediately just stop and never attack that system. They would just, no, I'm not going to be here, thanks. There it is. At this point, they were 100% focused on ransomware, and they used iron ransomware, which wasn't very sophisticated, wasn't very stealthy in a lot of aspects, even though their backdoor was called Iron Stealth or Iron Stealer. You know, they you know, had some aspects in it. They made some money, kind of got their feet off the ground, and working through that. Where they got a lot of their kick, you know, and like how they actually started funding everything was actually crypto mining. So they were using a lot of Monero. Monero is the currency of choice, a lot of crypto mining in that aspect. What they ended up doing is they were actually compromising Chrome extensions and IE extensions, specifically with a vulnerability found in AdBlock Plus. They would compromise AdBlock Plus, and then they would actually have that system. If Chrome or AIE would actually turn off for whatever reason, their script would be continually running, and once a minute it would check this to make sure that that was running, or that the browser was running. If not, it would just silently turn it back on and start the mining operation. They didn't use, they weren't very, they didn't use a lot of CPU process power. Everybody remember probably, it was around 2016, 2015 for sure, when all of the crypto miner systems were using like 90%, 95% of systems, and like servers were actually melting because crypto mining was just going insane. Does anybody remember, you know, some of that stuff? So they learned, right? They were like, well, maybe we should use 10 or 15 or 30% of the CPU process and try to keep that a little bit quieter. So they, you know, they did learn how to do that. You know, the software that they did in order to target these systems was X-Agent, the JBoss miner, and they also, you know, obviously requested ransom for Bitcoin, Monero, and Ethereum primarily within those. So again, using very commodity processes, nothing special, very scripted. However, that kind of changed in around May of 2018, and a little bit earlier than that, around you know, through the first of the year, December 2017. And this is when Unit 42 first picked them up, and we actually converted their name from Iron Group to XBatch, and we gave them a pretty cool graphic. Right now, they're actually important. And that's why, because what we were able to find is they were actually now starting to actually isolate and hone in their target on a specific type of aspect. They're actually now focusing solely on ELF binaries. Can anybody understand, you know, try to think of why ELF binaries would probably be important in our day and age today? What's that? Okay, how about cloud, right? You know, Linux AMI systems in AWS. You're looking at Ubuntu systems that are being, you know, spun up, containers running solely on Alpine or Ubuntu or you know whatever Arc. You know, so ELF binaries are an easy way to cross all your different Unix platforms. At this point, they were actually considered a botnet. They actually started dabbling in to something. They've been compared to NotPetya, and they, which uses internal blue, like what Ray was just saying about earlier. However, they weren't very good at it because they're where Eternal Blue was actually using SMB, to propagate from system to system to system, and you go lateral movement across using SMB1. They actually used weak passwords and unpatched vulnerabilities of their victims. So, it's not really a sure way of like firing a botnet off really heavily. You're not going to get thousands and thousands of systems, but they did pretty good, even with just weak passwords and unpatched vulnerabilities because they're in the cloud, as we'll get to in a second. Their targets are primarily, still do a little bit of Windows, but their targets are Linux heavy, massively Linux. But what they did within this environment at this time was they targeted specifically databases, specifically MySQL, and Postgres, and MongoDB, were the primary three. And they exploited these systems using vulnerabilities that were pretty old, really, for the most part. A Hadoop vulnerability, a Redis vulnerability, an active MQ vulnerability from 2015, 2016. So again, unpatched systems that are web servers, and unpatched, DNS systems, unpatched systems that may be holding some sort of database in the background. But it's kind of fake news and fake ransomware because it was interesting because they would actually first compromise the system and then they would go into a specific database and then they actually just start deleting tables. They would just delete as many tables as they wanted. They put up a fake table in there with the ransom message and they say, hey, give me a ransomware, I'll give you your data back. Well, the tables are deleted, so you never get it back. But however, they still got 48 unique payments out of that and they made about $8,000 US during that time. So it still worked, people paid. Right, so kind of interesting. But again, I guess that chunk of change, even though it's only like $8,000, it was allowed to elevate their level. So that was from May, and then in August they came out. But around the same time, around April, they actually started a whole new type of venture, and this is where they focus like solely on cloud. Talos actually at first originally found this via honeypot, these particular types of malware systems that they were working with, and they evolved, pretty significantly. But we're still able to tie some of their work back into both XBash and Iron Group via their Cold Strike was used within their PE miner and also their XM rig malware that they were using. There's a lot of conversions between those. But what they really started using is they're really starting to leverage cloud infrastructure, or I guess in this case GitHub, Git repositories, and pastebin repos very extensively. They started holding their initial infection C2 code up in GitLab and GitLead. Is anybody familiar with GitLead? Has everybody heard of GitLead before? And also, this is China's equivalent of a GitLab. Okay, so if anybody in the United States has any communication going to GitE for whatever reason, you probably don't need to do that. So just let me all know. But they do hold a lot of their malware up in this environment. This is when they also started actually perfecting and isolating a very specific type of downloader that they would use, and put their backend. This is where Kerberos comes into the mix. We'll get into its functionality and how it actually kind of works in the TTPs that Rock uses in the next little section. They kind of changed their tactics a little bit, and now they're focusing solely on like web servers. They're starting focusing on what are those components that you'll most likely find within the cloud, and they found those within Apache Struts, Adobe Cloud Focus, and Oracle WebLogic. Just general web servers that are out there and running, operating. So these are the primary targets they would look for. What they would do in a brief overall summary is, Greg mentioned with crypto mining, it's very common if you get into a system, you want to kill all the processes that are like competing with you. Rock did a little bit different on that one. They get into that system and then they put IP tables on, so you even kill that process, and if they had some sort of recursion that would come back on, and persistence that would bring that system back on, they'd also add IP table rules to that particular system, and it would just like stop all network communication. So that's their box. This is the interesting thing. This is where we really started getting really interested in Rock, because not only did they stop the crypto mining processes, they would actually go into the cloud system itself, and they would actually start targeting Alibaba and Tencent specifically, which actually have cloud security protection systems in place. If that cloud service protection system was in place, they would go ahead and terminate that system, and then they would actually follow Alibaba and Tencent's own process of uninstalling those processes from their cloud environments, and then just completely remove them from that system to begin with. So this is the first time where we've actually seen crypto mining operations or a cloud actor in a specific instance actually taking specific actions to remove it, like actual security tools from their systems. Which is kind of cool, right? I think that's interesting. It's an interesting target. They also started doing something, they also started adding rootkit functionality to it. And that's very basic rootkit functionality. Has everybody heard of lib process hider? What lib process hider does is it actually hides the XM rig process from the PS command under Linux terminal. So you just type PS and it gives you your whole task list, basically. This just hides it from that. Obviously, memory forensics can pull it back, and there's ways to get around that. But now we're actually seeing the attackers actually starting to sink themselves deeper into the system and try to remain unhidden, or more hidden, undiscovered. If you want more information, on lib-process hider, which is a cool process. There's hiding Linux processes on Profit. It was written by Guyan Luca Borello. I'm guessing he's Italian. Does anybody know him? All right. Yeah, he's a GitHub lab where he wrote that. So it's a cool tool. So now Rock's they've kind of gone from script kiddies. Now they're actually getting a little bit more technical, getting a little bit more subversive, and now they're actually moving into new layers. And this new layer that we're talking about is now called God Lua. So God Lua was actually coined the term God because it actually switched the ASCII character of Lua for the ASCII character of God once it was decompiled. You can see that here. God Q, and that's why I thought, okay, yeah, all right, that's me. No, I was kidding. But yeah, so another thing that they actually do is now they're actually starting to alter their malware itself, right? So now that they're using Lua, they actually now changed their Lua that was running on the system, so now they actually altered it to a version of Lua being God 5.1. So there's a nice little trigger that we can start tracing. God Lua. With this new type of code, this new type of malware that they have, we start getting some more infrastructure development that we could go on. We have heyheyduck.tk, and they're using the subdomains of CED and DB. Then we also have cloudappconfig.com, and then you have the same subdomains of CED and DB, but they also have other ones like F and T and B and image 0, 1, and 2, which you'll see in a second, which fits kind of into their profile. Both of these domains, coincidentally enough, only and have ever only resolved to this particular IP address. So I call it the 101 because that's interesting. And I threw this up. Has anybody ever seen Darren Aronofsky's Pi? Amazing, right? It's amazing. I think it's an amazing movie. But within that, they're actually talking about the God number, which is this mathematician. He's building this whole new computer chip that's actually going to find this most improbabilistic number. It's like 433 characters long. It goes through this whole process. But then there's a whole bunch of Judaist Kabbalists come in and like say that's the name of God and we want that program and algorithm how to do it. And there's this whole film noir mind psychosis problem that's happening. It's a great movie, very niche, so enjoy. What this application really did is this actually shows that the actors have now evolved from being script kiddies to hiding themselves in the systems to actually building and generating a tool and an agent that actually can be on a cloud system that actually now has agent capabilities. So it has handshake capabilities, heartbeat capabilities, Lua scripting capabilities, 2 different kinds of shells, an upgrade tool. You can quit it, turn it off, you can proxy through it. So I mean, now it's actually becoming an actual proxy that you can actually use. It has been reported that it has been part of a DDoS campaign where it can now actually do DDoSing. If it does have Lua capabilities, just script a DDoS to actually go do it, right? And then I'm sure it can do it. I couldn't find that evidence actually happens with the malware, but it's reported it could, so sure. Shell, 2 different kinds of shells, and then this proxy. So now you have agent communication that you can chain communications through. So again, we're now getting sophisticated. How this links to Rock, we found it with the Kerberos downloader. There was communications with how the C2 node communicated back from the agent up to the C2 system. Well, we found domain crossovers. These are 4 of the domains that Rock has been known to use. All of these were registered by Luwei, so there's a good connection there. And then the C2 specifically calls to these 2 particular domains, which are also Rock domains. So that's a pretty heavy correlation. Also, how the malware itself behaves. They both write a hidden P file within the temp directory. They both try to disguise themselves as PNGs or JPEGs, which hence the subdomains being dimension 0, 1, 2. Kind of easily slide under the radar. And then they also use paste-pick very heavily for that initial compromise, that initial infection. So, how does Rock get into these environments? We talked a lot about the infrastructure and how they work. But before we can talk about that, we have to have the talk. And that talk is the cloud. So, what is the cloud? How does the cloud work? There is a good majority of you that are actually using the cloud, so take a nap. It's okay, I don't mind. So for those of us who don't know the cloud, because it is kind of complex, there is some complexity involved in it, and it can be a bar to entry for sure. So let's try to just lower that bar. There are three types of cloud networks or networks that we can have. The on-prem, which is not cloud, it is just what we normally have as data centers and systems and servers running in racks on systems. These are all on location. They're all traditional networking. They are your applications running on your systems in your data center, right? You own and operate. Private cloud changes a little bit. They're your operating systems, or they're your applications. They're still running in your systems, but it's not running in a system anymore. It's now actually running in a shared hierarchy system. So like say VMsphere, or vSphere, or some sort of like Zen server, or something of that nature. So now you have one application that can be sharing resources or increase the resources of that particular application to fit the needs of how the application is supposed to run. So you know where they are, you know where they're physically located. Public cloud now changes this. This is where we start bringing in AWS, GCP, Azure, Alibaba, DigitalOcean, whatever. They are now your applications running in someone else's hardware. Okay? You don't know what they are, and you don't know where they're being located. I mean, you could probably specify, I want this to be run in this region, and they have to agree to that if that's part of your SOW or whatever. But you really don't know, and quite frankly, you probably don't even care. You just want the system to be up and running. Here's this in pictures. Our on-prem situation, everything's on our system right over here, and there's our buildings, there's our firewall, there's our internet, all our stuff is inside underneath that firewall. Cool. We jump over here to the private cloud. We have all of our systems. We have our own cloud that's serving all of our particular applications that all of our users connect to, but if we want to get to the internet, we have to go through the firewall. Pretty straightforward. But the public cloud is, we have our systems with our users and all of our laptops. We have to go through the firewall first, get to the internet, to get to the cloud, which has all of our applications. Again, pretty straightforward. In pictures, it's definitely helps. Now we're going to make things a little bit different. Containers. Everybody's probably heard the term Docker's Kubernetes, so let's try to make that granular and bring everything down to a small level. So a Docker is a virtual machine for a single application in and of itself. It doesn't do anything else. That VM, that container VM, has the resources, only has the essential resources of the OS for that application to run. So if you don't need to have network connectivity to it, you will not have a NAC for that system, right? That's just an example. If you don't need a library for whatever process that you need to have for Adobe, but you're not running any Adobe, you're running something else completely, you're not going to use any of those libraries, right? So you're only going to use what it is. This allows for Dockers to be speedy. They're quick to stand up. Instead of taking an operating system 4 minutes to stand up, you can have a Docker stand up within 30 seconds, maybe 15 seconds, depending on how powerful or how much it has to start running. You can make changes to that Docker's configuration template. You can turn that Docker system off, turn it back on again, and it's completely updated for whatever it is that you have. So when it comes to patching systems, all you have to do is patch the template, turn that system off, turn that system back on again, now you're fully patched. You don't have to go through the patch cycle, it's automatically changed. Kind of nice, kind of handy. It's great for developers, it's great for pen testers and research people because you have the exact same environment every single time you turn the system on or off. It makes it, it's faster for VM testing. Kubernetes, take Docker, and then now take Docker and times it by 4, and then you have to manage all those systems. Kubernetes does that for you. Kubernetes will manage Docker instances. It'll manage a lot of different types of container instances. It'll manage multiple containers. It ensures that system has a stability in the application. If that application crashes for whatever reason, Kubernetes will turn it back on, so on and so on. It's modular, it's architectural, and it creates redundant application. All good so far? Fantastic. We're going to talk about just the stack real fast. On our left, your left, my right, we have here the virtual machine as we know it. I'm just going to say type 2, so we're just going to say that this is VMware as opposed to Zen server. You have your bare metal system, your infrastructure itself. You're running an operating system on top of that system. You have your hypervisor, which in this case would be like, VM Fusion or Workstation or whatever. Then inside of that, you have each individual guest OSs. These boxes are fully encapsulated operating systems, right? It is everything the entire operating system has, and then you can run applications on top of that. Containers on the other end, you have bare metal systems, you have an operating system, and then you'll have Docker container engine running right here, or Mesos or Kubernetes or whatever you have. And then inside of that, you have a container specifically for the application itself. So what you've done is you've essentially eliminated your guest OS. There's an issue between this and this and this and this. We have a strong isolation and a weak isolation. Wow, holy crap, that's so slow. I'm going to bust through this real fast. There's container escapes that go through this. It means this is all OS. This application is more secure for a file than this system is to the host operating system, right? All right. So there's container escapes that go through this. So now, how do organizations actually do with the cloud, taking this new type of orchestration? My team and I, we created a report. It's called the Cloud Chance of Entropy. And we go through and we start looking at what is the state of cloud right now, right? Okay, what is the cloud that we live in and how vulnerable is it? What are misconfigurations? Within 2018, up to current day, we found that 65% of all reported incidents are due to misconfiguration in the cloud. This is S3 buckets being misconfigured and exposed. This is failure to have user authentication in front of elastic searches, systems, a lot of different things that go into this. We also found that 39% of all organizations have RDP exposed to the internet. Just on. You ready for that number? Ready for this number? 56% have SSH exposed to the internet. Okay. You could have these under authentication. They could be safe. They could be secure. It's fine. You'll see in a second that maybe not. But 56 are still just exposed. Okay. This is just the cloud. 61% of organizations are using TLS version 1.1, which was end of life in 2008 because of insecure encryption. Number one outcome of all of these things was data leakage. Everybody lost lots and lots and lots and lots of data. Vulnerabilities in the cloud. These numbers are insane. 34 million exposed vulnerabilities just in the cloud. Huge caveat, this is not Amazon, this is not Google, this is not Azure, this is not DigitalOcean. These are not the cloud service provider vulnerabilities. These are client vulnerabilities occurring on cloud infrastructure. Okay, so these are your applications. 29 million are in AWS. There's a breakdown of those particular systems. 4 million in GCP, 1.7 million in Azure. So users actually using these systems. These are more staggering to me. 22 million of the 34 million are CVE 18 or older. Okay, 4 million are CVE 14 or older. So these are old CVEs. You know, they're out there. They're good. These are the top vulnerabilities that we found within CVEs. We have Apache HTTP, we have Apache HTTP, we have OpenSSH, number 3 and number 4. So 56% of systems have SSH open. Number 3 and number 4 are the top vulnerabilities. So 2 and 2. That makes attackers go, oh, all right, let's just hop in here. Which is what we found. So now we're going back to Rock. This is the cyber operations, TTP steps of Rock. It's a 12-step process where they upload their information to Pastebin, but they entice their victim to download that somehow. They exploit that vulnerability on their system using whatever, Web Oracle or WebLogic or Adobe Cold Fusion, what have you. The victim downloads it, connects back to a C2 node that they control, downloads the C2 environment, downloads the payload. They gain administrative access to that particular container, whatever that is. So now they have root access on that particular system because most users run their containers in root, which is awesome. Establish persistence in the cron job command, so now they have persistence. They go ahead and search for those crypto mining processes, kill those off, add IPT to those rules to block future communications, uninstall the cloud agents, download and install Monero, and then now we have, now they rootkit. So pretty good rundown. So this is what we know about Rock. These are the domains, the Lua domains that we know. These are the one-on-one domains that we know. There's a few other reported domains. You can see here that, 3389 is actually a domain that I actually use, so you might want to trust that or have maybe 3389 open to people. That would be really cool. More registration names. So again, the ground truth commonality of this, what I did is I took all those domains, I resolved their IP addresses to what they have available. I found that 4 of the domains resolved to these 2 IP addresses. These domains resolved to 2 of more of the domains that were actually being used, and there's 50 other IP addresses that were used. So what I did is I graphed those, made a pretty little picture out of it. You can see that these are probably important. You can probably see that these are probably important because they're used by a lot of different IPs and a lot of different domains, so we kind of wanted to do some pretty little graphs. And then we document this. Unit 42 is this really cool, everybody know the MITRE map? We have done something called the attack template. We use the MITRE framework, and then we take all of our different attacker groups. You might know some of these names like Oil Rig and Sophisy and Emissary Panda and Rock Group and Cobalt Gang. We're adding new ones to these all the time. So, I mean, Unicorn is a threat intel shop. This is completely free and available. You can download this as a Stixtaxi feed, upload it in your system, and hopefully you're protected. So, good stuff. There's the Playbook viewer right there. Go use it. Search and destroy. Now we're going to sift through the sentiment. So Rock did all this stuff. So I took all those IPs. Oh no, this is the best part. Can I skip questions?
1 more minute and then 4 minutes of Q&A.
Okay, I'll skip questions. This is really cool and scary. Everybody that raised your hand for cloud, raise your hand. A third of you, I don't know how many of it is, a third of you keep your hands up. You're all infected by Rock. 30%, nearly 30% of all cloud organizations are compromised by Rock. We started out as a script kidding compromise and have matured to the point of actually compromising 30% of cloud. That's huge. 22% of those, or 2% of the total, have sustained beaconing traffic up to 6 months, from what I can find. So every hour on the hour, every 15 minutes, they're beaconing in your environment. If you are connected to one Rock domain, there's an 83% chance you're connected to multiple. And the most common ports are 443, 80, 51, 640, which I think is amazing, and 10.0.21. So cool ports to have. The 12-step indications that I wanted to use, I wanted to take the 12 steps, with the GitHub, the pastebin up through contact of the domain. You can see here that I looked for pastebin domains, and then any time it happened within the exact same hour, connected to anything else. So you can see that. You can see initial confirmations that the client is reaching out to pastebin, downloading the initial C2. C2 is generated on that particular system and reaches out to a cloud domain, or to a Rock domain. And the beacon's every 15 minutes. So yeah, this all has to be over NetFlow. So there we go. Rock uses weak passwords, so change your passwords, use more extreme passwords. Update your vulnerabilities and patch, please. Please patch your cloud systems. Other findings, we went over some of these, but this was really interesting. 50% of Azure containers use passwords, not key pairs. At AWS and GCP, mandate that you use a key pair instead of a password. Azure does not, so 50% of people don't. Why not? Firewalls, block with firewalls. VPC traffic monitoring, still buggy. I'll talk to you about that if you're interested. Oldie but a goodie is NetFlow. NetFlow is your savior in this because full packet capture does not exist in cloud. It doesn't exist. So you have to use old school technology being firewalls and NetFlow. That's how I found this, which is Rocke'in the NetFlow. So you can block all this stuff, get to your threat feeds. Prisma Cloud has online IP blocking. Go and get a hold of the player Playbook download, get that into your environment, stop those IPs from going through, and or use Prisma Cloud because it does it automatically. So there we go.
2 minutes.
2 minutes. Go ahead. Yeah. Question.
The 30% of compromised cloud customers, whatever.
Yes.
Is it 30% of Palo Alto's visibility or 3% of all everywhere?
It is primary Palo Alto visibility, but it's also cloud everywhere, and it's cross-platform. So it's not just. So the question was 30% of Palo Alto customers only, or Palo Alto organizations, worldwide. We didn't limit our scope just upon our clients. We looked at as much data as we possibly can, asked for permission to look at stuff. We found clients outside of us, outside of Palo Alto, that are compromised that fit the same pattern. I don't know about every single client because I can't have visibility over everything. Yeah. Other questions? All right. Please see me more if you're interested about cloud, container security, how to stop, prevent anything. Please let me know. I love talking about cloud. It's good stuff. So there we go.